Hello, my name is RWood, and this is my Business Intelligence Vendor presentation for CIS 570. The company I chose is Pixia Corporation. Pixia Corporation provides solutions for efficient delivery of geospatial data, motion imagery, and video in a cloud-based service-oriented architecture. The solutions as a service they provide are data as a service. They provide this due to the demand of fast, efficient access to the data is growing exponentially. And as the data sets grow, they become increasingly more difficult to store, access, utilize, and share. So Pixia provides the solution. They also provide a platform for this service by presenting the underlying set of HTTP-based access. They represent and transcode the data. Pixia has a web-based solution to provide a platform of a cloud service. Pixia Corporation at a glance. Corporation is privately held and founded in 1999. There are approximately 70 employees, and the global headquarters is in Reston, Virginia. The chief executive is Rudy Ernst. Timeline of the history of Pixia Corporation. In 1999, former Disney and Pixar employees found Pixia in New York. They were both in the entertainment media industry and wanted to use their skills to be able to provide solutions for the big data. Their focus was always in government, but after 2001 and 9/11, they moved their headquarters to Washington, D.C. in order to focus their efforts in defense. In 2002, they had their first sales of their high-performance data solutions to the U.S. government. In 2005, Pixia played a major role in the Department of Homeland Security efforts for Hurricane Katrina and Irma. In 2006, they provided the first support of wide-array motion imagery sensor data. And in 2009 was the first year the company made profit. In 2012, they opened an office here in Denver and took their technology and provided it free to the community of the Open Geospatial Consortium. So the solutions they offer, they call HyperLook, HyperStare, and HyperWatch. The Hyper stands for high performance. HyperLook is their heritage system for legacy data. It's used for cataloging, organizing, and sharing large volumes of geo-intelligent data. They provide it on a thick or thin client with instant access via this HTTP RESTful web service that they deploy to the OGC. It's deployable and it can detach from network environments. The HyperStare is for our traditional modern big data. The access to large volumes of the wide area motion imagery, or WAMI, within the cloud-based architecture in reach for deployment using this RESTful web-based service technologies. And the solutions that they provide, the data is gathered through many independent sources for whatever the needs may be. And their new technology is called HyperWatch. It's for the emerging big data. It's going to allow the organization and sharing of the new generation sensor data that comes in high definition, full motion video through this cloud-based architecture. So now we can take a look at their HyperLook technology. So they have a demo loaded on their website. And I'm going to use this demo hosted by the U.S. Department of Agriculture. So as you can see, it's deployable to either your desktop or a handheld version. And the Department of Agriculture uses this to track growing patterns of crops throughout the United States. When it first pulls up, it looks to me almost like a bad version of Google Maps. But as you go through the data, you see that it's not just the satellite data derived from the NASA satellites that Google uses, Worldview and such, but it is from the independent Department of Agriculture satellites, so they have different specifications and different focuses. It has the same Google-like zoom features, double click, you can scroll and pan across. And you can zoom in here, we can take it to Colorado and keep zooming in until we get to Fort Collins area and see what that looks like. So as you can see, they're able to track the crop growing patterns for this data, and this is only a one-time snapshot. This would be available through a feed so they could compare it to last season, the season before, and come up with different data. Their HyperStare technology is a similar web-based architecture. And this provides for full motion video, data tracking through independent sensors, through satellites, through whatever information is provided. So in this case, the demo is from Whitby Harbor in England. And as you can see, we have a timeline down here. And so this is 40 minutes of elapsed time, but you can watch it frame by frame in slow speeds, or you can speed it up, pause it. And from this data, you can see the traffic flow through that time. They have it so you can add a pop-up. So if you want to focus on just a certain area, you can set the pop-up area so you can have this there and scroll around and look at other things while you're focusing on that. And you can set up multiple pop-up layers to focus on the different imagery that you need to see. So that would be very useful, in the intelligence and defense market, also in the, homeland security, even city planning, so you can see traffic flows through different areas. So get the presentation going for you. So the data flow processes which they provided to the community is this. The source data comes in, goes into their engine services, and from there they fire off alerts for any necessary media, but then the majority of the data goes into these container files. These container files are what allows Pixia to organize and simplify the data to be able to be disseminated either through the data services or through the cloud platform services they provide. So as you can see in their HyperLook platform, the admin server collects the data, and then from there it goes through to their containers where it organizes the data. From this it uses the RESTful HTTP and then provided through thin client, thick client, or the mobile app to the end user. And this provides quick access to this data. The HyperStare technology is even faster. It takes the wide array motion imagery data into those same containers and then streams it straight to the end user. So there's no server side, it goes directly to them. So the majority of the customers for Pixia are governmental customers. They have the Air Force, Navy, Corps of Engineers, Department of Agriculture, United States Africa Command, Department of Homeland Security, and the U.S. Geospatial Intelligence Agency. They are a sole source to the government for this type of technology. They have no competition in the market for these governmental applications. Again, the use of service and military with all the surveillance ops, sensory data, and satellite collections, sensors on vehicles. They're able to collect that and use that, organize it and store it through these services here. The current wars in Iraq and Afghanistan have demonstrated how valuable this information is. It could have uses in civilian life as well. We saw on the Department of Agriculture website that they were able to track their farm growth and crops throughout the year. It could also be used in city planning to monitor traffic flows, figure out, if you need to put a new stoplight in, where a good place for building is. So when you see a satellite view or you're looking at it, you can see the ground and the layout better for designs of buildings. I thought an insurance company could use this data, and they could see when someone inputs a claim, they could pull up the location where the accident happened via street cameras that are in use by the government for some of the traffic monitoring, but use that and determine who was really at fault of the accident. So after using the demonstration of this, I found that their strengths, they have developed a strong platform that is easily portable and interfaces well with many of the customer applications and programs. And they provided this technology to the community to share their knowledge, so there would be a standard platform for sharing geospatial data. Again, the ease of use is also a characteristic of using the Pixia servers. Let's say their weaknesses as a company are they have a narrow target market. They have limited use to the highly specialized data that they collect and provide, which also gives them their edge. But I think in a commercial market, they'd be competing with Google, who really have a much simpler interface. And if you're searching for things, routes, places, maps, places, you can mark out your own trails and landmarks. All of that is really easily accessible to a commercial consumer via Google Earth or Google Maps. So it's going to have a hard time breaking into that market. Highlight some of their achievements and assessments from other people in the industry. So the Geospatial Intelligence Forum thinks highly of them, and they feel that they vastly know how to control the data. Booz Allen Hamilton says that they're great at building applications and architecture that run the data cloud, and it requires new thinking for scale, elasticity, and resilience. And they feel that Pixia covers this. Also, in 2013, they were the winner of the US GIF Industry Achievement Award. That's the United States Geoinformation Forum. And to close it off with my references, use the Pixia website, the Geo Community website, GIS Cafe, and the National Space Symposium. Thank you.